Find dy over dx. Is it just like a normal differentiation, or do you have to do something?
So, yeah.
Oh, it's y cubed. So it's
Sorry, yeah, go on.
like 3x squared
Mm-hmm.
plus 1, and then is it like then 3y squared dy over dx
Yep.
plus 3 dy over dx
Yep.
equals 6. Oh wait, what happens to 6? Does it just go?
You tell me.
Well, if you put it on the other side and then differentiate, it just goes, doesn't it?
And so,
And then I don't know what happens.
you just get the derivative of it as normal.
What?
Derivative of 6.
Just nothing.
There you go. Okay, I think you're good there.
What? Did you just leave it like that?
Yeah, done. Oh, sorry. They want dy dx. Okay, so you have to rearrange it to get dy dx equals.
Okay, so if we put both the dy and dx onto one side,
Mm-hmm.
so 3x squared plus 1 equals minus 3y squared plus 3 dy over dx. If you put that all in brackets, then dy over dx.
I just moved the others to the other side.
Okay. So then, if you put that onto the side, then it's 3y squared. If you put it, do you want to put it all in brackets and just do dy over dx on the outside of the bracket?
Yeah, factorize.
Yeah. And then put dy over dx equals minus 3x squared minus 1 over 3y squared plus 3.
Yeah. Any questions there? I think you're very good for that. Given that that equals 10, find dy dx at the point 1, 1. How would we find dy dx at the point 1, 1 for this?
Differentiate.
Mm-hmm.
Do what we did before, and then once we've got dy over dx as a subject, put 1, 1 into the x and y.
Yep. So you would just sub 1 for x and 1 for y.
Yeah.
And so they're just differentiating as normal. Find the values at the point 1 over e to 2x ln y. Okay. Things are getting interesting. So it's differentiation. Oops. Okay. How about this?
So 2e to x differentiate 1 over y dx.
You have two things multiplied by each other? Two functions? Yep.
So u equals e2x, v equals ln y, du over dx equals 2e2x, dv over dx equals 1 over y,
Yep.
dy over dx. Do you put the dy over dx then as well?
Well, we have to actually do dy dx first.
Okay, so just 1 over y then. So then e2x times 1 over y.
Yeah.
Plus 2e2x times ln y.
Something's missing from the first. Oh yeah, the dy dx. Is that what you were talking about?
Yeah.
Yeah.
So then do you put ln y? Do you leave that ln y?
Yeah, because you didn't differentiate it.
Okay. So then you get e2x over y dy over dx plus. Oh, it's getting complicated. Plus ln y 2e2x.
Yeah, that can just stay the same.
Yeah. And then that equals x plus, that equals 1, because if you differentiate the other side, plus 1 dy over dx. Yeah. And then
Okay.
what do you do after that? Just leave it?
At the point 1, 1.
Oh, you have to. What do you do with the dy's and dx's? Do you collect them or something?
Yeah, you could do that at this point, or you could do it at the end. I think it's probably easier to do it now.
Okay, so dy over dx bracket e2x over y plus 1.
Tell you what, try subbing
That,
in. Try subbing
yeah,
in the ones first.
yeah, that's complicated. Right. E 2 1 1. Oh, we're doing in radians or degrees? Doesn't matter.
Doesn't matter.
Okay, so e to the power of 2 plus 2e to the power of 2. And then gives you, wait,
Don't forget your dy dx.
what do you do with dy dx? Oh, yeah, just put it there. And then 1 gives you 0, so that's all 0 then.
Okay.
Equals 1 plus 1 dy over dx. So Then you put the dy over dx into the side. To cut the terms, then you get dy over dx bracket e squared plus 1 equals 1, and then dy over dx equals 1 over e squared plus 1.
Minus 1, I believe.
Why? Oh, yeah.
1 over e squared minus 1. You said minus the first time.
Oh.
There you go. Yeah, so I thought it might be like some good practice, but actually it was just needlessly complicated. Yeah, just sub in the 1 and minus 1 as soon as you've differentiated, and just watch for the product rule.
Okay.
Any questions there?
No.
Okay. So, alright. 7 markers. Yeah. So, any of these you like the look of?
What, like a specific one?
I think that's a goodie. They've got trig as well.
Okay. Do a trig one as well. They all 7 marks?
So the trig one is 7 marks in total because it's got A and B.
I can do them all because they're all really different.
Alright.
Depending how long it takes. Okay, so dy, what's the question? Find equation of a tangent to C at the point 1 minus 2. So dy over dx, 4x plus 6y dy over dx minus 1 plus 6 dy over dx equals 0. Then we have 6y dy over dx plus 6 dy over dx equals... Oh wait, do we have coordinates? Did you say to put the coordinates in straight away?
I think it'd be easier, yeah.
Okay.
And don't forget your method mark of writing them down in a bracket instead of x and y.
4 1 plus 6 minus 2 dy over dx minus 1 plus 6 dy over dx equals 4 minus 12 dy over dx minus 1 plus 6 dy over dx 3 equals... Is that what equals it? So if you put 12 and then minus 6 equals 6 dy over dx. Dy over dx equals a half, and then it's the tangent, so that minus 2.
What did you get for dy dx?
half.
So I'm getting minus 1.5.
Hang on, let me check. 4 minus 1 is 3. Put the 12 dy over dx minus the 6 dy over dx. So you get 6 dy over dx. 3 divided
I
by
get minus 6 dy dx. So y is minus 2. X is 1.
hang on. 4x plus 6y dy over dx minus 1 plus... Oh, you put a 6x... Oh, it doesn't make any difference, it's still 1.
Okay.
Oh, wait, what? You put 6x dy over dx plus 6y.
Yeah. So the derivative of 6x is 6.
Yeah.
And so it's 6 times y. So it's first times derivative of second plus second times derivative of first.
But don't they just go?
What did you get for that part?
But you've got 2 parts for 1 term.
So product rule for 6xy.
Oh, it's a big product rule. Hang on. Then you put the coordinates in, which were 1 minus 2. So 4 plus 6 minus 2 divided by dx. Okay, so dy over dx equals minus 1.5. And then tangent, do you have to do the negative reciprocal or is it the same?
You tell me.
I don't know, because I swear I wrote down when I did the normal.
So normal, what do you do?
I feel like I do the negative reciprocal.
Yep.
So then the tangent, so you just keep the same gradient.
Yep, parallel.
Okay, so y minus, well, plus 2 equals minus 3 over 2 x minus 1. 2y plus 4 equals minus 3x plus 3. So then we get 3x 3x plus 2y plus 1 equals 0.
3x plus 2y. That's b plus. So what you got?
Yeah.
3, 2, 1. Okay. Yeah, just watch out for product rule, I suppose. Very commonly, they put the x and y together. Any questions there?
Nope.
And I lazily used minus 9 minus 6 dy dx equals 0. I just solved it using that thing.
Yeah, well, I don't have that.
All right. You do in there somewhere. I'd have to. I finally got through the Chinese website and I should be able to do it. Is 8 too easy?
Yeah. Oh, wait. Is it?
What's the derivative of 3 to the x?
I don't know.
I think it's 3 to the x ln 3.
Did we get it in the formula book?
Yeah, I think so.
Check.
So 3. I'm just going to see what happens. Shift that. 3. No.
You have to put the x. I always think that, and then no, it doesn't work. Because x needs to have a number.
And let's give it the number 1. And I'm thinking that that's going to be 3 times ln 3.
3.295. Yeah.
And so, yeah, it's the derivative is 3 to the x
Wait, how
ln
did
3.
that change?
Sorry?
It said 3 ln 3 on it. How did you do that?
I manually put in 3 ln 3.
Oh. That's impressive.
So y equals a to the x. dy by dx is equal to any number to the x ln whatever that number is.
Equals a to the x ln a.
Yeah.
A to the x. So 3. So a equals 3, so it's 3x. So would it be 3x ln 3?
Yep.
Okay. 3x ln 3.
Yeah.
Okay.
How about 9? What are you washing?
Outside. That doesn't look nice.
Why? What was outside? I could hear birds earlier.
Yeah, it's very nice and sunny. The window's open, that's why. X, X. I haven't been outside. Oh my god. When was the last time I was outside? I haven't been outside for like a couple of solid days.
Ah.
I know.
Hate that.
Yeah, especially when it's sunny. Okay, so ln y squared equals half x ln. Mate, this looks quite hard. I want to do this. At the point on the curve where x equals 4, give your answer as exact. So ln y squared, is that the same as 1 over y squared dy over dx?
Yes, and there's one more thing.
What?
what is the derivative of y squared?
Oh, so 1 over 2y.
I believe it's 1 over y squared.
What? What?
Can you hear me? You're back, I think. So chain rule?
Chain rule for what?
So y squared is its own thing. So I think you multiply by the derivative of the function inside the function.
Y squared equals half. 2 ln y. What? Oh yeah, 2 over y.
Ah, yeah. 2 over y dy dx. There we go.
Equals half x, which is just, oh no, is this like product rule or something?
Yep.
It's not even hard, it's just effort. U equals half x. Does v equal ln x minus 1 then?
Mm-hmm.
Right, let's see how that one goes. So du over dx is a half, and dv over dx is 1 over x minus 1.
Yep.
So then you get half x times 1 over x minus 1 plus half ln x minus 1 in brackets. So 1 over 2x squared minus 1. Oh no, 2x squared minus 2x.
At the point of x. I would. You don't need to simplify it. You can start substituting.
So just leave us half x times 1 over x minus 1.
Yeah.
Plus half ln. Okay. So, okay. Half x times 1 over x minus 1
Well, what is x?
plus half ln, no, what is it? 4. X minus 1, substitute. So 2 over y dy over dx equals half 4 times 1 over 3. So 2 over 3 plus half ln 3. Which is three. Actually, I might just leave it as that for the moment. What's the question? Find the gradient. Oh, okay. Oh, it's 2 over y. How do you get? So you have to times y to that side. How do you get the? What do you do with y?
You have to find y.
How do I find y? How do I find y?
How do you usually find the y coordinate?
Make x equals 0.
That's the y-intercept. Y-coordinate?
I don't know.
So usually it's written as y equals, and you would sub it into the original.
So I've got to put 4 back into the original.
Yeah.
Oh, God. Okay, hang on. ln y squared equals half 4 ln, so 2 ln 3. ln y squared equals 2 ln 3. To get rid of ln, you do e, but I don't know how much that's going to help.
Yeah, it's fine.
Yeah, but then, so y squared equals e to the 2 ln 3. The e to the ln, doesn't that just leave you 1? Oh no.
So
Can't do e to the ln. So y squared equals e to the ln to 2 ln 3.
well, y squared will be equal to e to the power of all of that.
Yeah, which is that 2 ln 3.
2 ln 3.
Yeah.
That's just a number. Oh, give your answer as an exact value. Snake does.
We're just working out the y coordinate, aren't we? Wait, what? Oh yeah, so we can put it in and then times it and then find dy over dx.
So that's y squared.
So y equals root e to ln 3. Then you put that in the thingamajig. So dy over dx equals 2 over 3 plus half ln 3 times by root e to ln 3 over 2, which then, as you can simplify, but this looks a bit complex. I must have messed up somewhere.
What did you do? So I just rewrote this. So if you do the two separately, the square root of e squared is e.
Yeah.
And ln 3 to the half is the same as square root of ln 3.
Yeah.
And because it's a log, you can bring the power to the front. And so a half e ln 3 is that.
Yeah. Oh wait, no. Hang on. That's the same as e half ln 3.
Yeah, same thing.
And then dy over dx equals 2 over 3 plus half ln 3 plus half e ln 3 over 2. No, that's still hard. That's still quite different.
So is it 2 over 3 plus a half ln 3?
Yeah, plus the half e ln 3 if you put the 1 to that side.
It'd be times, wouldn't it?
Times it, sorry.
Yeah. E ln 3 over 3.
Half a quarter e ln 3
So ln 3 squared.
Whoa, whoa. Where'd you get elon 3 over 3?
2/3 times a half elon 3. 2 times a half is 1. So elon 3/3.
Oh, okay. Elon 3 over 3 plus a quarter. There's two lots of elon 3, so how would you do that? Oh, yeah, okay. Makes sense. Over 2.
Yeah. And that's equal to dy dx. Give your answers an exact value. There you go. That's exact. They can like it. They cannot like it. I suppose we can. That'll be over 6 if you're halving it. 6, and then this one will be. You could always multiply it by 2 because bring the power forward. But you don't have to. Anyway, it's done. That's a half, that's a quarter.
What's the answer?
We have the answer there. It might not be in the form they'd like it to be. Hang on. So, e ln 3 over, I believe, over 4. You could get a common denominator. What, 24?
What's 2 times a quarter?
A half?
So a half over 2 gives you a quarter, so it's over 4. So elon 3. Yes, okay. Whoa.
I just put it into one fraction. So one is eln 3 over 6, the other is eln 3 over 4. And just added the 2.
Over 24.
Ah, yeah. They didn't do half of the work that we did. They just left it like that.
But what? 3 over 4. Where did they get 3 over 4 from? They just times 1 quarter by 3 to get rid of that, so they did elon. No.
Anyway. Done. Big and difficult.
I hope that doesn't come in the exam.
Yeah, we all do. Let's see, that's 9. Let's see, 10 was the trig one. I think we should do one trig thing. This is easier because it's not just one huge question, it's split up for you.
Math sucks.
It loves you regardless. Learn to love it. 1.8.
I need to learn it, love it for 3 more weeks. That's mental. She says, and then ends up having to do loads of them. Curse is that by sin x is called y equals 0.5 by pi over line expression for dy dx. Sin x plus cos y equals 0.5 y over dx.
Oh, stationary points. I'm running to the toilet. I'll let you do that.
What do they do?
Then sin y dy dx cos x equals sin y dy over dx dy over dx equals cos x over dy over sine, and then implicit differentiation.
How'd you get on there?
So dy over dx equals cos x over sine y,
Okay.
and then so to find the stationary point, dy over dx has to equal 0.
Mm-hmm.
So cos x over sine y equals 0. And then I got stuck.
A fraction equals 0.
Yeah.
What does that tell you?
That cos x equals sine y.
No. A over b is equal to 0. How can a fraction be equal to 0? Give me two numbers for a and b.
Zero and one. One must be 0.
Which one?
No. A has to be 0.
Yep.
So cos x equals 0.
Yep.
Therefore, in radians, cos minus 1, 0 gives us pi over 2. And what's the range? That one's a bit too long. Two pi over 3.
Yeah. 3 pi over 2, isn't it? 2 pi minus a half pi.
Isn't 3 pi over 2 above the ring?
Yeah, so I think there's just one answer then. The coordinates. Okay, so that's the x coordinate. No, stationary points.
Yeah. Can I just put in the calculator?
Yeah, calculator.
I feel like that they don't like that though. To be fair, I always put in the calculator and I work it backwards.
So second answer is 2 pi minus pi over 2. So, but that's outside the thing.
So cos
It's minus pi.
x equals sine y. How do I get a different y?
Ah, I see it. There is a second answer.
2 pi over 3.
Minus a half pi. So cos they just have a strange.
Oh yeah.
They just have a strange range. From minus pi to positive pi. Usually it's from 0 to 2 pi or something like that. And so, what? So that's the x coordinate. What's the y coordinate? How did you get the y coordinate?
I don't know. Put it back
Into which one?
into the equation.
Yep.
Which equation is the question? Which equation do I put it in? The original one.
Yes.
0.5 minus half. That did not work.
Sine a half pi?
Oh, I forgot to put the... Wait, what did we just work out? X or cos?
We just worked out the x coordinates.
But we used cos to work out the X. Oh yeah, because we differentiate it.
Mm-hmm.
So I put a half pi into the equation they gave us or into the one we made.
So the stationary point, so the graph is going to look something like that. These are the two stationary points. The x coordinate is a half pi and minus a half pi. Just use your calculator magic. Put that in your calculator and cheat.
What equation do I put in?
The original, sine x plus cos y equals 0.5.
Yeah. That was sine x. I don't actually know how to get a y on here though.
So I don't either, and maybe you can't do it implicitly. I wanted to do the calculator for all this, but implicit snagged me.
Maybe options, numeric, angle, finance, logic. Implicit. What? Hyperbole, no. Calc, no. Prob, no. Logic, no. Stat, no. Finance, no. Angle, no. But that's let me do that.
I think you have the thing anyway. What is sine a half pi?
1.
Yep. So you have 1 plus cos y.
So cos minus 1 that. Oh, 2/3 pi. Lol.
So that's 2/3 pi. Wait, 2/3 pi.
Yep.
Okay, and the other one?
Minus 2/3 pi.
Sub it in. So sub in minus a half pi.
minus a half. Right, sine minus. I wish they made the half pi button a bit more easier than having to push it. Minus 1, so minus 1, so 0. So 0.5 minus 1. No, so you add the 1. Then cos minus 1 of that does not give you an answer.
It's outside the range, is it?
So it's sine x equals minus 1. 0.5 plus 1 gives you whatever, 1.5. Then cos minus 1 of that should give you an answer, but it's giving me a non-real error. Can you not do cos minus 1.5?
There are no solutions for that one, and therefore the stationary points are pi over 2, 2 pi over 3, and pi over 2 minus 2 pi over 3. There you go. Any questions there?
No.
Well, that's implicit differentiation. It sucks. What can you do? Hopefully there's some way in your calculator to do it. Anything in particular you want for next time?
Next Thursday.
Will you have had your first test by then?
I'm on the June the 5th, which is next Wednesday. So Thursday we can so we'd have had one.
And I'll see if they have any predicted papers. I don't think they do for A-level, because you can't really...
So if it's in the first paper, will it come up in the second paper? Topics.
No, but isn't it like one is pure, one is stats, mechanics?
You get 2 pure and 1 stats.
Ah, okay. So yeah, so I'll check for predicted papers then for paper 2, because they won't...
I mean, apart from things like integration, differentiation, which will always come up, but if they put sequences and series in one paper, they're probably not going to put it in the next, are they?
I think it would depend on the type of thing that comes up for the first one. So it might be a different type of differentiation or something.
Yeah, that's still going to come up in both. Or something like algebraic fractions or binomial expansion.
So
You can do it once, really.
I'll check predicted paper.
Okay.
Any questions in general?
No.
Right. Well done, Saba.